which birds are breeding in these boxes, and what happens to the nestlings in those boxes. And so the data Casey gave me go all the way back to 2004. So basically 20 years of breeding data from these bluebird boxes. And I'm just curious, how many people in the room have been monitors on the bluebird trail? Wow, that's great. Have any of you looked at the data before, or is this a first?
We can't look at it as you would.
Okay. All right. Okay. So the first thing I did with the data was very basic, very simple, and that is to look at who's nesting in these boxes. And the first thing I found is probably not a big surprise to you folks who monitor the bluebird trail, but the bluebird trail is maybe a misnomer. so these boxes, the number one occupant is the hero of our story tonight, the tree swallow. So over those 20 years, 1,891 boxes have been occupied by a pair of tree swallows. So the eastern bluebird is pulling up second place. So they're the silver medalist here with 1,538 boxes. And then there's a big drop from that. The bronze medalist is the northern house wren at 640. And then over the 20 years that we have data, there are a host of birds that make up a very small fraction. The house sparrows, who are sort of an unwanted tenant in these houses, Carolina chickadee, and then one occurrence each over the 20 years, tufted titmouse, Carolina wren, and one of the big surprises over the years, red-headed woodpecker. So the tree swallows, one of the nice things about the bluebird trails, the tree swallows offer us an awful lot of data with almost 1,900 nesting attempts in these boxes. The tree swallow differs from the other primary users of these boxes in several important ways. So the number bluebird, the eastern bluebird, unlike the tree swallow, is a permanent resident here at Blandy. So these again are Cornell eBird data, and you can see that the bluebird is regularly seen at Blandy every week of the year. You have to go out of your way to come to Blandy and not see a bluebird. House wrens, like the tree swallow, are migratory, and with the exception of a single year where somebody turned up a very late house wren in January, house wrens, for the most part, don't arrive until mid-April. That's when they arrive, which is a full month and a half behind the tree swallow. So migrant, but arriving quite a bit later. So I'd like to propose that the tree swallow is maybe a really interesting species to look at as far as a response to climate change for three reasons. Number one, its breeding range is gigantic. It covers so much of North America, so it's a species that could be studied over a very, very broad geographic scale. Number two, it arrives so early. And so it's easy to imagine that the species that might be first affected by a warming climate might be those species that are at the very front of the migration line, coming in during those coolest months of the spring. And then thirdly, it's a good candidate, I think, because its breeding biology is so observable because it so readily uses these human-made nests. So the first thing I wanted to do when I started looking at these data was just to establish whether or not we've actually seen much change in the climate here at Blandy. And so, very fortunately, we have another long data set here at Blandy. So this is Bob Arnold, who was the arborist here at Blandy, beginning in the 1970s. Bob had the longest tenure of any employee ever in the history of the Blandy experiment. And in 1984, Bob was given charge of keeping the weather data here at Blandy, and Bob was meticulous in collecting that weather data. And so this was before my time. I heard he was in the hospital for a while, and he saw to it that the weather data got collected here at Blandy. So we have a very complete data set of temperature data and rainfall data here at Blandy since 1984. So I wanted to look at these data and see how much our springtime temperatures are changing. And so I looked at this period that was available to me, 1984 through this most recent spring, 2025. And there are lots of different ways I could have looked at this data. So what I decided to do was, based on the biology of the tree swallow, I divided the data, or first of all, I subsetted the data to include only March and April. I thought those were the two most relevant months for this bird that arrives roughly during the first week of March and begins breeding, as you'll see, in late April or early May. So from Bob's weather data set, I used the months of March and April, and I divided those data up into early in the month, the first 15 days of the month, and then late in the month, the subsequent 15 or 16 days. From that data, a few things became pretty evident. First of all, the time periods that showed the biggest effect were the early periods in each month. So early March and early April saw the largest effects. Secondly, the minimum temperature, so the average lows during those time periods showed bigger effects than the average high temperatures. All right? So that's the take-home message. For those of you who want to explore this in a little more detail, there are a bunch of numbers on these graphs, and I want to sort of walk you through them and tell you what's going on here. Ariel didn't mention it, but so for the last 27 years at the University of Virginia, I've been teaching the statistics course in so this is one of my passions. And so, how many of you are statistics majors? Oh my God! All right. I didn't expect anybody.
Hey, Dave, my wife is as well.
All right, so I want to point out a few important numbers here so that you can appreciate these graphs. One important number is right here, that this P is equal to number. So for statisticians, that's the bottom line number. This is basically telling us something about how much confidence we have in the conclusions of this analysis. And in statistics, we have this convention that we want to be 95% confident before we go out on a limb and say something, all right? That corresponds to a p-value that is less than 0.05. So this p-value of 0.02 is telling me, it's sort of flashing, there's something going on here, all right? And so what that 0.05 is telling me, or that in this case 0.02 is telling me, is basically I can be about 98% confident in what I'm about to tell you, all right? And so what I am about to tell you is here at Blandy, in early March, temperatures have shown a tendency to increase during that period from 1984 to 2025. Temperatures, the minimum temperature here at Blandy has risen from about negative 1.8 degrees, that's 28.8 degrees Fahrenheit, to 0.64 degrees, so slightly below freezing to slightly above freezing. So 0.64 corresponds to about 33 degrees. So that is a change in temperature of about 2.4 degrees Celsius. That's a pretty big change. 28.8 degrees to 33.2 degrees Fahrenheit. And like I said, this number here tells me I can be about 98% certain or confident that that's a real trend. That certainly makes the case that at least for the minimum temperature in early March, temperatures are going up. Another interesting number here is right here. It's this R squared number. And in this case, that you probably can't read that from the back, but 0.1279. So that R squared number varies from 0 to 1. And what you can think for that number, the way you can think about it is that that's telling us something about predictability. How predictable is this change in temperature through time? And so a value of 0 means no predictability whatsoever. Basically, the temperature is varying randomly. An R square of 1 means that temperature is perfectly predictable. In which case, if I know what the temperature is here in 2025, I can tell you exactly what it's going to be in early March 2026. All right? But we know, weather is never perfectly predictable. So this is saying that predictability is about 13%, which is not high. It's not awful for these kinds of data, but what it means is that there's a lot of variability here. see it in the scatter of these points. But the trend is fairly strong. Minimum temperature is increasing. The maximum temperature is also increasing by about 1.9 degrees Celsius. But if you look at the p-value here, it's much larger than 0.05. And so that's telling me I can't be very confident about that conclusion that the high temperature it has been increasing since 1984. And you can see correspondingly the R square here is 0.03. So that means very low predictability, close to zero predictability on the maximum temperature. So we do see an effect on minimum temperature over time, not so much with the maximum temperature in March. If you look at April, again, the biggest trends seem to be for the data in the first half of the month, early April. And again, we see a rise in the minimum temperature. The p-value is less than 0.05. So again, in this case, I'm more than 99% confident that something really is going on there. Again, it's about almost a 2 degree, 1.9 degree change in temperature since 1984. And, that's in degrees Celsius, so that's a pretty substantial difference in minimum temperature. If you look at the early maximum temperature, the high temperatures in April, they're going up too. I'm just barely above that magic 0.05 there, so I can only be about 92 or 93% confident in these conclusions. But again, the temperature, the maximum temperature has risen about 2.2 degrees in those early April temperatures. The R squares here, pretty good for the minimum temperature at about 0.159. But again, there's a lot more variability, it seems, in the maximum temperature with an R square of only 0.07. So the maximum temperature seems to have much more noise in it, but the minimum temperature seems to be rising pretty significantly in the spring here at Blandy. So what about the tree swallows? So what are the tree swallows doing? So with the tree swallows, we don't go all the way back to 1984. Those data only go back to 2004. But the trend is, first of all, a couple things I need to explain about this graph. First of all, is Julian date. If you're not familiar with the term Julian date, it's something that scientists use to convert calendar dates into a continuous number. So January 1st is Julian date 1, February 1st is Julian date 32, okay, and so on and so forth. If you look at this, the second thing I need to explain is, so what is the first nesting? When should I say the tree swallows are starting to nest? And so there are a lot of different ways I could have done this. I could have just taken the first nest that was recorded, but that can be pretty variable. There could be, a really ambitious pair of tree swallows out there that started well before everybody else. And so what I did was I picked the first 5%. So how long did it take for the first 5% of the nest to get started. And this the number of nests that involved varied from year to year, but it's somewhere between 3 and 5 nests each year. So the first 3 or 5 nests. And so if you look at the beginning of these data, you can see that the first 5% of nests are happening on about day 120, and then the Julian date gets less and less. That means the Julian date gets earlier and earlier in the year. And so in the last 20 years, the onset of tree swallow nesting is defined by that first 5%. Has been happening about 3.8 days earlier, so almost 4 days earlier than it was 20 years ago. So that's not much, but 20 years is not that long a time. So these tree swallows do seem to be responding somewhat. My p-value is tantalizingly close to that 0.05 mark, but it's not quite below 0.05. So I'm about 96% confident, or pardon, 94% confident here, rather than that 95%. You had a question? Oh. So we're not quite at that 95% threshold yet, but something does look like it's going on here. The R-square is about 18%, so not great, but that's pretty strong for ecological data. I would not be surprised with a few more years of data collection that this effect shows up to be significant. So it very well may be that these tree swallows are in fact beginning to nest earlier in the year. I took a look at the Bluebird data from the trail, and the line is flat. Bluebirds start breeding on about April 13th. And bluebirds were breeding on about April 13th in 2004, and in 2024 they're still breeding on about April the 13th. So to me, this suggests that maybe it really is something about the biology of the tree swallow, this migratory behavior that is responding to changes in climate here at Blandy. So the next thing I wanted to do was to ask the question, okay, so we see this trend in earlier and earlier tree swallow nesting. Not quite significant, but very interesting trend there. We saw that there are differences in temperature over the last 40 years here at Blandy. I have those temperature data. How well do the temperature data predict when these tree swallows are going to start nesting? And so I modeled this, and I asked the computer to pick the best model for predicting when tree swallows are going to start nesting. I gave it the choice between the temperature in early March, late March, early April, or late April, and I gave it the minimum temperatures and the maximum temperatures. So I fed that into the computer, and I said, of those 8 variables, pick out the combination of variables that do the best job at predicting when tree swallows are going to nest. And what it came back with is that one variable does the best job at predicting when the tree swallows are going to nest. And that variable was the maximum temperature in early March. Even though that's not, that was extremely variable. It does not show a significant trend over the last 40 years. It is increasing. The trend is toward increasing temperature, but remember my p-value was about 0.25. It was not yet very convincing that there's a long-term trend going on there. But that early March temperature does a pretty good job at predicting when these tree swallows are going to start nesting. So in this case, the relationship is quite significant. So I am more than 99% confident that the conclusions of this analysis are pointing to a real trend. And the R-square here is higher than any other analysis I did before. The R-square is almost 0.35, which for ecological data, that's pretty darn good. And what I'm seeing in these data is if you have a cool early March where the maximum temperature only rises to about averages about 12.5 degrees. The tree swallows here at Blandy will start nesting by about May the 2nd. In a really warm March, where those early March temperatures are on the order of about 24 degrees. And first of all, I was pretty amazed that the average March temperature can vary here at Blandy by like 12 degrees C from year to year. So that March is, it's a variable month, right? Comes in like a lion, goes out like a lamb. Sometimes apparently it comes in like a lamb. On a warm March, the tree swallows are nesting, the first 5% of tree swallows are nesting by the 25th of April, a week earlier. So in the warmest Marches, the tree swallows are nesting a week earlier than they're nesting in the coldest Marches. Yeah, I thought that was pretty interesting. So climate, these tree swallows do seem to be responding to climate. The climate does seem to be trending to warmer springs. The next thing I asked was, does it matter? So are these tree swallows doing okay, whether they nest a little bit earlier or a little bit later? And so I looked into this, and so I looked at these data in two different ways. First of all, I had to decide what does success mean, and so in at least this first look at the data, I decided to define success as getting any fledglings out of the box. So success is fledging at least one baby from the box. Failure is 0 babies. So if you don't get anybody out, you get a 0. If you get somebody out, you get a score of 1. You're successful. And then I looked at the tree swallows that nested in March, which it turned out there were no tree swallows, I think, that started and nested in March, April, or May. So I looked at in those months and asked, is there a change in success based on, or from 2004 to 2024, our most recent data. And then I asked the question, does that early March temperature that seems to be such a good predictor of when tree swallows start nesting, does that predict success or failure? So if you look at success over the course from 2004 to 2024, the good news is that success is slightly increasing. And here my p-value is getting close to 0.01, so I'm close to 99% certain about this. It's not gigantic, but it comes in, the probability of success back in 2004 was a little bit below 75%. The probability of success now in 2024 was about 77%. So not a huge difference, but the tree swallows are doing a little bit better. I thought it was impressive that it was that high, that fledgling success was that high at all. If you look at the relationship between success and that early March temperature, it told a slightly different story. So as that March temperature, early March temperature got warmer, nesting success actually, the probability of nesting success actually decreased, and again, significantly so. Again, I'm like 98.5% confident in this trend. Cool months, cool marches, which also translate into later nesting, remember, success is highest. And in the warmest months, which, remember, translates into early nesting, like a week earlier, those have the lowest success. Again, it's not huge. It still is somewhere in that 75%, so that's the good news. But this earlier nesting may be leading to slightly more nest failures on the part of these tree swallows. A warming temperature might be increasing, even, perhaps slightly, the risk to these nesting tree swallows. So that's as far as I've gotten with the data so far. But the great thing about what all you volunteers are doing in collecting these data is that for the last 20 years, Casey has been sharing those data with the Nest Watch program at Cornell University. And so what's going on here at Blandy can be compared to what's going on elsewhere in that giant breeding range of the tree swallow. And so projects like the Bluebird Trail here can be multiplied by all the other Bluebird Trail tree swallow nest box monitoring that's going on elsewhere in the country. And we'll be able to better understand whether the trends that we're seeing here at Blandy are widespread, that there's this overall advancement of the date of first nesting of tree swallows, and how that might be affecting the nesting success of the tree swallows. So take-home messages are tree swallows are the earliest breeding migrant here at Blandy. Over the past 4 decades, those early March March temperatures seem to be rising, especially the minimum temperatures, the low temperatures in the month. Since 2004, tree swallows have shown a strong trend, they're not significant, of earlier nesting, very close to significance, but not quite. Higher maximum temperatures seem to predict earlier nesting by the tree swallows, but those higher temperatures may reduce fledging success. And then I think just as important, my take-homes are that these long-term data sets are increasingly valuable for our understanding of our biggest environmental problems, and that the role citizen scientists play in expanding our capacity in creating these big data sets that span years and span great geographical scales are really contributing to our understanding of these environmental problems. So I think that's all I have. I'm happy to take questions, but as soon as we're finished, we'll go out into the field.
So the tree swallow is arriving earlier and occupies the box at the same time, so maybe before the bluebird starts occupying the box. Will the tree swallow eventually outcompete the bluebird?
Yeah, so I looked at when the onset of tree swallow nesting and bluebird nesting and compared the two. And over your 20 years, bluebirds, I showed you, they are their nesting date is not changing, but they are still way ahead of the tree swallows. So the average bluebird is nesting on April 13th, and that seems to be independent of anything, how warm it is, or 1984 compared to 2004. But the average tree swallow, even in the warmest years, is nesting is starting on the 25th of April. So 13 days later. So it is going to take a while, it looks like, for tree swallow nesting to get ahead of bluebird nesting. That said, I'm only looking at that first 5%, and I haven't looked to see whether there is more overlap in the nesting phenologies of the two species. And if there's more overlap, that's potential for more competition for nest boxes. And so I know you perceive a trend of tree swallows occupying a higher proportion of the boxes. If there's more overlap, that could be driving it.
Dave?
At my house, there's one box in the front yard, in the garden, where most of the time bluebirds are in there end of March. Like the last 2 weeks of March, they sometimes got eggs already. This year, bluebird went in there and started making its nest and everything. And 1st of April, around the first week of April, the tree swallow pushed him out and took over the box. And it had eggs filled early.
Do you see tree swallows usurping bluebird boxes here? Do you have a sense?
Yeah, I think so.
So Dave, given that bluebirds are non-migratory and the tree swallows are, what's your thought about the effect of climate south of here on these differences?
Yeah, so, I guess I'm a little surprised that bluebirds aren't responding as well. But I don't know what cues they're responding to. Maybe it's day length. So day length is not changing, right? Even though temperature is. So whatever it is that's telling the bluebirds it's time to nest, at least, based on these 20 years of observation, that doesn't seem to be changing. The tree swallows, they're insectivores, right? So they're coming up, feeding on insects, and so they can't be up here too soon. I think one of the potential problems of them arriving too early is if you get a cold spell for a while, those insects aren't available, and so that could result in the death of the tree swallow or the failure of a nest if they nest too early. I imagine that the tree swallows are tracking temperature all through the south, and so it's warming here by 2 degrees in March. If you go further south, it's probably warming by that much or more, and they're just they're following the spring. They're following the emergence of insects up here. Like Casey said, or implied, if it warms enough, they're going to be arriving the same time as bluebirds are ready to nest.
And there's been a temperature increase. Each year, did it increase more? Or is it like a domino effect where the hotter it gets quicker?
Yeah, so I didn't look for that. So I think what you're asking is it getting warmer faster?
Yes.
And I didn't look for that in the data. I just looked for what we call a linear trend. As noisy as the data are, I probably don't have sort of the statistical oomph to detect a nonlinear trend there. You probably need a longer set of data to see if it's accelerating. All right. You want to go look at some tree swallows? So Casey's got a map